Today's lesson will be about graphing sine and cosine functions. We will graph the other trig functions as well, but for now we're going to concentrate on sine and cosine. And so I want to show you, we're going to start with sine, and I want to show you this little applet that will kind of explain how sine and cosine are related to the unit circle. So here is the sine function. I know this is kind of small, so hopefully you can kind of blow this up on your screen, but I want you to see how the sine graph is generated from the unit circle. Okay, remember that sine is your opposite over your hypotenuse, and some of you have figured out that sine is really your y value or your up-down value anytime you make a triangle or you're measuring things on the unit circle. Sine is your up-down value. So when you think about how your up-down value changes as you move around the unit circle, this is how the sine graph is created. So I'm going to just kind of draw this, and this is fast motion, but this is what happens, okay? In slow motion, this is what it looks like. As I'm measuring my sine value right here, over here it is 0, okay? As you move around the unit circle, obviously your up-down value or your sine value, your opposite, the opposite side of the triangle, which is the red over here, is getting bigger. And so your graph gets bigger and 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 bigger till it hits right here. And now that sine value is 1. And so that's what happens. I'm going to actually clear this out and start over so that you can see this. So your up-down value is getting bigger and bigger and bigger and bigger and bigger in that first quadrant. Notice I'm still in the first quadrant. It hits 1. It maxes out at 1. Now that up-down value or your sine value or your opposite side is getting smaller in the second quadrant until at 180 it hits 0. And it's still getting smaller, only now they're negative in the third quadrant. Smaller and smaller and smaller until it bottoms out at -1. And then in the fourth quadrant it gets bigger again until it gets back to 0. And if I were to repeat this cycle, the same pattern would happen. It would go up and down and up and down and up and down, and so that pattern would repeat. It would start right here, it would make an up curve, a down curve, repeat, up curve, down curve, repeat. Okay, but that is how the sine curve is created, or the sine graph is created from the unit circle. This is just the basic sine equation. Nothing has been done to it. So this is the basic sine function. What I want you to notice is that it repeats every time you make a trip around the circle. So it has what's called a period, and we'll talk about that in a minute, but it has a period of 2 pi. If you look at the domain, there is no value that I cannot plug in. There's no value that along my x-axis that it can't be. Along your y-axis, though, if you look at the range of this, remember the range is what your y's can be. The biggest my y can be is 1, and the smallest my y can be is -1. So it has a range between -1 and 1, just so you know that. And that is on the pictures of your graphs, just so you know. So we are going to go back and do some things on our graphing calculators to kind of demonstrate what happens when you change this basic sine equation, okay? So I want you to pull up your graphing calculators, and we are going to graph some different functions on here. Okay, first of all, I want everybody to be in radian mode, so I need you to go to your calculator. I need you to press the mode button, and I need you to be in radian mode. Mine is in radian mode, but if it's not, make sure you put it in radian mode and hit enter. Then I want you to go to your window, and we are going to put our window at some different spots. And so I am going to put my window, my x-min of my window at, let's say, negative, let's go pi over 8. Okay. My x-max will be at 2 pi. And once I hit enter, it'll turn to a decimal. And then let's go x scale of pi over 4. And let's go y min at -5, y max at 5, y scale at 1, and the x resolution you shouldn't need to touch. Okay? So again, x min was -pi over 8, x max we did 2 pi, x scale we did pi over 4, and then obviously you can see the y min and y maxes. Okay? Now I want you to go up first of all, everybody turn off their stat plots because we probably have some plots turned on from before. So before we try and graph this, let's go and do this. Let's go second, y equals number 4, and then enter until it says done so that we aren't messing our calculators up. Okay, now we want to graph some equations. So we are going to go into y equals right here. And the first function we're going to graph is just sine of x. And so if we do that and hit graph, this is what it should look like. Just like the applet we just watched. This is the basic sine function. Notice it starts at the origin right here. It goes, maxes out at 1 after the first quadrant, and then back to 0 at the third quadrant, bottoms out at -1, and then back to 0 for the end of the fourth quadrant. So this is the basic sine function. What I want you to do is leave that one in y1, and then we're going to manipulate that. And so we are going to go back here, and the next thing I want you to graph is negative sine x and see what happens there. So we're going to put in negative sine x. And when you throw that negative in front, I want you to notice how the graph becomes manipulated or changed or transformed. And so when we hit graph, you can see what that negative does is it flips that graph over the x-axis. What was a high point becomes a low point, and vice versa. Okay? Then we're going to go back. I'm going to clear out y2. And the next function I want you to graph is 2 sine x. Okay, so 2 sine of x. So now when you throw that 2 in front of there, I want you to think about what that does to your graph. And notice what that did is it made your high points a little higher and your low points a little lower. It really affects what is called the amplitude. The amplitude is the distance between the midline, and in this case, the x-axis right here that you see is the midline. Okay, so the difference between the midline and then the high and the low point is your amplitude. So notice my midline is at 0, my high point now is at 2. That distance is 2, and that is called the amplitude. Okay, so that's what it affects. It just stretches the graph vertically. Obviously, if you had an amplitude, or if you threw a 1/2 in front of that equation, if I went back here and I threw a 1/2 instead of a 2 in front of there, it would compress the graph, so it would make it shorter, and then your distance between your midline and your high and low points would only be 1/2. Okay, so that's what throwing a number in front does. It affects what's called the amplitude. I'm going to clear that out. And we're going to go back. Now I want you to graph sine of 2x. So putting that 2 in a different place this time. Notice what that did is it made you have curves more often. It makes you have twice as many cycles or periods in the same amount of time. Okay, a period is the distance it takes before the pattern starts to repeat itself. That normal distance is 2 pi, okay, because that's one trip around the unit circle, and then it starts to repeat itself. But when you throw a 2 into that equation, where you did right here, it makes you have twice as many periods in the same amount of time. So now instead of your period being 2 pi, now your period is only 1 pi before that pattern begins to repeat itself. Because it would go up and down, and it would start to repeat itself halfway through right here. So now your period is only 1 pi. Okay? So that's what that does. A couple more here. Now I want you to go sine of x, close your parentheses, and then add 2 to it. And let's see what that does to the graph. And you can see what that did is it moved the entire graph up 2 units. It did not change the period. It did not change the amplitude. All it did was move the entire graph up 2 units. And now instead of your midline being your x-axis, your midline is going to be up here. Halfway between your high and your low point is your midline. Okay? And now your midline is at 2 instead of at 0. Okay? Instead of at the x-axis. And we're going to do one more, and I don't know that this is on your sheet, but we are going to do it. And we're going to do this. Let's go sine of x, and let's go minus, and then in parentheses, pi over 4. Like that. Okay, and now we're going to see what that does to the graph. And it's kind of hard to see here, but what that does to the graph is that, I wish they could color code these for us, but they don't. What that did to the graph is it moved it pi over 4 to the right. Okay? Even though there was a minus in the equation, we did x minus pi over 4, it moved it to pi over 4 to the right. It did not change the period, it did not change the amplitude, it just shifted the graph over along the x-axis. So now it just crosses at different points is all. Okay? So now that you kind of know that, we are going to be graphing some by hand here in a minute because you need to know how to do that. But first of all, I want you to look at a cosine function with me really quick. So that was the sine function, and now I want you to look at the cosine function. On your unit circle, your cosine is your adjacent side, or your x value on your unit circle. And so when you do cosine, this is what will happen. It will look something like this, and then you actually need to flip it. But this is what it will look like. So here we go. Your cosine value, notice when you start right there, is 1. I am 1 to the right when you begin your unit circle. And now your cosine value, oops, I didn't want to do that actually. Now your cosine value as you begin moving around the unit circle, your cosine value is getting smaller and smaller and smaller. Right here at the end of the first quadrant, your cosine value is 0. And then your cosine value continues to get smaller. And right here, your cosine, or your x value, or your adjacent side of your triangle, it hits -1. And then as you move into the third quadrant, your x value starts to get a little bit bigger until it hits, excuse me, hits 0 again. And then as you move around, and then the pattern just kind of repeats itself. So this is what the cosine curve looks like. Notice it does not start at the origin. Its starting point is at 1. It still has a period of 2 pi because that pattern starts to repeat itself over here clearly as you get to 360, but has a pattern of 2 pi. The domain would be all real numbers, and the range, the biggest y value you have is 1, and the smallest y value you have is -1. So your range goes from -1 to 1. Okay, so those are some sine and cosine functions, and now we're going to take a couple and we are going to graph them by hand. First of all, you have this formula on your master formula sheet. This is the equation that we base everything off of, and we've talked about some of these pieces before. I have the word sine in here, but you need to know that I can replace this with any trig function. I could replace it with sine, cosine, tangent, secant, or cosecant, okay? And we will talk about all of these pieces on here, but you need to have access to this formula, or this set of information as we're going through these graphs, okay? So we've talked a little bit about amplitude, midline, period. The phase shift is the left-right shift, and we will continue talking about some of these things as we move forward here. All right, so this is the first graph that we are going to do. We are going to graph the function 1/2 cosine of -3/4 x. Okay, first of all, you have to pay attention to the even and odd properties when you're doing this. This is why I made you practice the even and odd properties earlier. So you're going to pay attention to if there's a negative right here. If there's a negative out in front, you're not going to, the even and odd properties don't apply to that. Those rules do not apply there. The even and odd property rules only apply when you have a negative inside the parentheses like I do here. Okay? So I'm going to pay attention to that negative, and I'm going to remember that cosine is an even function, and on even functions that negative just gets to get dropped. Okay, so what you really have is you really have y equals 1/2 cosine of 3/4 x. Okay, so I'm going to have you kind of go through a bunch of different things here and sort of record this before we graph. Here's what I want to pay attention to. First of all, I'm noticing that there's not a negative out in front of there. If there was a negative out in front of there, excuse me, what that would do is it would flip the graph. It didn't, there is no negative, so it's not going to flip the graph. Okay, so I know that this graph is not flipped. This 1/2 right here affects its amplitude, and that affects its high and its low point. So I know that the amplitude is 1/2. Okay. Back here, there's really a +0. even though it's not written. And so I know that my midline, I'm going to get you in the habit of looking at that because that's going to change in the next couple days. But I know that my midline is 0, okay? And that kind of gives you your center point from high to low. And then I am going to recalculate my period. Normally a period on a cosine curve is 2 pi because it starts right here and it goes and it starts to repeat at 2 pi. But when I throw this 3/4 in front of that x, it changes my period. So my new period for sine and cosine when I do this, I would calculate it by going 2 pi over that number in front of the x, which is 3/4. Okay? Now, instead of dividing by 3/4, I can multiply by 4/3. And then when I multiply this out, I get 8 pi over 3. Okay? Now, I want you to know that cosine is normally, it's based on the 4 quadrants of the unit circle. There's the first quadrant, and the second quadrant, and the third quadrant, and the fourth quadrant. Okay, based on 4 quadrants. Its normal period is 2 pi, but when I throw that 3/4 x in here, this becomes my new period. But I still have to take that period and divide it into the 4 quadrants. Okay, so here we go. When we go to graph this, what you're going to do is you're going to create basically a new period. Okay, my new period in this case is 8 pi over 3. So I'm going to go and I'm going to make 4 quadrants. And at the end of that 4th quadrant is 8 pi over 3. Okay, because that's my new period. Then I need to split those that 8 pi over 3 into 4 quadrants and relabel them. Now, you could do, for this point right here, you can take half of 8 pi over 3. And half of 8 pi over 3 is like taking 8 pi over 3 times 1/2, which gives me 8 pi over 6. Which of course reduces to 4 pi over 3. Okay. Then to get this spot right here, I could cut that 4 pi over 3 in half. And by the way, when you multiply by 1/2, you're really doubling the bottom number. So 4 pi over 3 times 1/2 is 4 pi over 6, which is 2 pi over 3. The other way I could do it is I could take my whole period, which is 8 pi over 3, and this is 1/4 of that whole period. So I could go 8 pi over 3 times 1/4, and I would get the same results. I would get 8 pi over 12, which still reduces to 2 pi over 3. And you don't need to show me all this work. You're going to figure out shortcuts to do this. But that's some different approaches to it. Okay, so that point would be labeled as 2 pi over 3. Then this point right here is 3/4 of 8 pi over 3. So I would go 8 pi over 3 times 3/4. The 3's are going to cancel, and I will have 8 pi over 4, which is just 2 pi. Okay, so I need all 4 of those spots labeled. The other shortcut you can do to get that 3rd spot is this. I'm going to keep my denominator at 3 and be counting up by 2 pi's because my 2 pi is my numerator. So I could go, this is 2 pi over 3, this is 4 pi over 3, this is 6 pi over 3, but 6 pi over 3 reduces to 2 pi, and then 8 pi over 3. I think you can figure out that the next one would be 10 pi over 3, and you can keep counting up that way if you need to. Okay, so that's sort of a little shortcut for those of you who want that. I'm going to relabel this now. So it was 2 pi over 3, 4 pi over 3, 2 pi, and then 8 pi over 3. Okay, then we need to label our y-axis as well. Our midline is 0. And then my amplitude is 1/2, which means I'm going to go 1/2 up from 0, and I'm just going to label this then as 1/2. So I'm going to go 1/2 from 0 would be positive 1/2. 1/2 down from 0 would be negative 1/2. Okay, then what I'm going to do is I'm going to follow the basic shape of the normal cosine curve and kind of use this same pattern. So at the beginning it's at its high point, notice, and then for the first quadrant it goes down to the midline. So I'm going to do that same thing. I'm at its high point. For the first quadrant it goes down to the midline, And then I go up here. At the next quadrant, it's down here. At the third quadrant, it's here. And at the fourth quadrant, it goes back up. So I'm going to follow that same exact pattern and recreate my graph, just relabeled with a new period and a new all that good stuff. And this is a cosine, that cosine curve then, all graphed and nice and pretty. Okay, so there's that. We're going to do one more together. This time we're going to do a sine curve. Okay, so a sine curve right here. We have this negative out in front, so we have to pay attention to that. Again, one more time, if you have a negative out here, you cannot drop it or pull it out or whatever. The even and odd properties don't apply there. The even and odd properties only apply to those negatives that are inside the parentheses. Okay, sine happens to be an even function, so I need to take this negative and pull it out in front out here. And so what my equation really becomes is this. Okay, so I want you to kind of go through those things again. Because I have a negative right here, that means that my graph is flipped, and I'll talk about what that means in a minute. This 4 out here affects its amplitude, so I know that my amplitude is 4. Again, I have a plus 0 back here, and so my midline is 0. And then my period, and by the way, I have nothing else added on inside the parentheses, so I don't have a phase shift here, but my period will be 2 pi over the number in front of the x. So my period will be 2 pi over 2 pi over 7. And then I'm going to flip that. So instead of dividing by 2 pi over 7, I'm going to multiply by 7 over 2 pi. My 2 pi's will cancel, and I will just have a period of 7. Okay? So I'm going to go down here, and I'm going to relabel everything again. Again, sine 2 is based on 4 quadrants of the unit circle, and so I'm going to make 4 quadrants when I make my graph. The end of that 4th quadrant will be 7. Okay? And I'm going to try not to I'm going to just teach you how to do this. I know you could use decimals, but I'm going to teach you how to do this with fractions because that's where people are going to get tripped up. Okay, so what I like to do is you could take 7 times 1/4 right here, and you'll see that this is 7/4. You could take 7 times 1/2 here, and this would be 7/2. You could take 7 times 3/4, and this would be 21/4 right here. And then just 7. Okay? The other thing you could do is cut 7 1/2 right here, so it'll be 7/2. Cut that in half, so I double the bottom number, and it would be 7/4. And I'm going to count out by 7. So 7/4. This would actually be 14/4, but that reduces to 7/2. 21/4, and then 28/4 reduces to 7. Okay? However you want to do it, it doesn't matter. Okay, my midline is 0. And then my amplitude is 4. So I need to go 4 up from my midline. So 0 plus 4 is 4. And 4 down from my midline. 0 minus 4 is -4. Okay. And then we are going to graph this. Okay, so this is a sine curve. Sine normally starts at the origin right here, which it will, but it normally goes up first, okay? However, this one is flipped, so when I flip it, it's going to look like this instead. So it's going to be opposite of what it looks like. Normally it would go up. This one is going to go down, okay? So I will start at the origin. I'm going to go down and back up. So it's going to look like this at the end of the first quadrant, this at the end of the second quadrant, this at the end of the third quadrant, and this at the end of the fourth quadrant. And that is what that sine curve would look like. Okay? And by the way, if a cosine curve is flipped, we should kind of graph this quick, because I didn't do one before. A cosine curve, instead of it starting up, it would start down, and a cosine curve flipped would look like this, just so you know, because that probably will come up in your homework. Okay? So that should do it for today. Hopefully you have somewhat of a grasp on this. I know it's all new, so hang in there.